All right, today we're going to be learning about geometric sequences and series. A geometric sequence follows a pattern of multiplication the ratio between any two terms is always the same. So just like with arithmetic sequences, they were adding the same number each time. Geometric sequences multiply by the same number each time. So let's look at the following three sequences. We're going to determine whether they're arithmetic, geometric, or neither. So in number 1, we have 1, -4, 16, -64. Does this seem like it's geometric, arithmetic, or neither? This one's geometric, and we're multiplying by 4 each time. So we have a common ratio, which we're going to use the letter R, of -4. Number 2 would be neither. It adds 3, then it adds 5, or it doubles, and then it adds 3 again, so it's doing too many different things. Number 3 is arithmetic. It goes from 3 to 6 to 9 to 12, which means we have a common difference of 3. We're adding 3 each time. So let's look at the first formula for geometric. A sub n equals a sub 1 times r to the n minus 1 power. So find the nth term. Remember from our arithmetic video that this means write an equation. To write the equation, we need to know what the first term is and what our common ratio is. Here, first term is 4. And our common ratio, what are we multiplying by each time? We're multiplying by 3. So our nth term, or our equation, would be a sub n equals 4. We typically write the common ratio in parentheses, times 3 to the n minus 1 power. You cannot, never, ever, 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 ever multiply the 4 with the 3 and make it 12 to the n minus 1. That is a much different sequence. That is a much different rule. You're breaking the laws of math by doing that. It's not allowed. You can't simplify it. This is it. Stop there. All right, so number 5, write the rule. Again, write the rule means write an equation. So, same two things we need to know. We need to know the first term, and we need to know the common ratio. We got the common ratio. We just don't know what the first term is. There's two ways of doing this. We could say that -12 times a to the first times -2, we know it's the third term, minus 1 power. 3 minus 1 is 2. -2 squared is positive 4. -12 equals a sub 1 times -4, or sorry, 4. Got it back. Sorry, -2 squared is positive 4. Divide both sides by 4. And we get that the first term is -3. The other thing you could do is, if we multiplied by -2 to go forward, we could divide by -2 to go backwards. So a sub 2 would be -12 divided by negative 2, which is 6, which means a sub 1 is 6 divided by negative 2, which is negative 3. Either way works for me. Either show me this work or show me this work. Not really picky. Just show me some math. So that means our a sub n, our rule would be a sub n equals negative 3 times negative 2 to the n minus 1 power. On to sums. So as long as the ratio doesn't equal 1, which it won't, our sum is going to be the first term times 1 minus our ratio to the number of terms we have divided by 1 minus the ratio. So here's our a sub 1. We need to know what our r is. What are we doing each time? We're multiplying by 4. And our n is 12. So s sub n is going to equal 2 times 1 minus 4 to the 12th power all over 1 minus 4. Make sure when you're on your calculator you're doing alpha, y equals, enter, and taking advantage of that flat fraction. Otherwise this whole top part has to be in parentheses. So 2 times 1 minus 4 to the 12th power all over 1 minus 4. So if we add up the first 12 terms when we're adding from 2 on, we get that the sum of this is equal to 11,148,810. Adds up pretty quickly. If it's written in sigma notation, you should be able to tell what your first term is and what your ratio is from the way we wrote the equations in the first couple examples. So your number out front, that's your a sub 1, and your number in your parentheses is your common ratio. So s sub n equals 1/2, or 0.5, times 1 minus 6, our number of terms. We're going from 1 to 10, so that's 10 terms, all over 1 minus 6. Type that in your calculator, and we get that the sum of all those terms will be 6,046,617.5. Now something different that we can do with geometric sequences is find the infinite sum. What if we added on forever? What would happen? We can only use this formula when our ratio is less than 1. Very, very important that the ratio be less than 1 for this formula to work. If you try to do it with anything greater than 1, you're going to have a problem. So here, our first term is 6. And then our common ratio. What's happening each time? What do we multiply by to go from 6 to 3? Well, we cut it in half. 3 is half of what 6 is. 3 halves is what half of what 3 is. 3/4 is half of what 3 halves was. So our common ratio is 1/2. So our infinite sum is going to equal 6 divided by 1 minus 1/2. Type that in your calculator. Alpha y equals, enter, 6 over 1 minus alpha y equals, enter. You can put more than one fraction in a fraction. Close your parentheses. If we added up all the terms forever, we would eventually get to 12. The reason for this being is each time we're cutting the pieces in half. So the pieces are getting smaller and 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 smaller. So eventually the pieces get so teeny tiny that they basically stop having an effect on what they add up to and eventually add up to 12. Now, what if our common ratio is bigger than 1? If the absolute value of your ratio is greater than 1, then there is no sum. Because in that case, your numbers just keep getting bigger, and therefore you would be adding forever, and it would never stop making a difference in the number. That's all for today. See you in class.